Welcome to our second lesson on the Doppler effect. We'll be looking at some of our calculations concerning the Doppler effect. Now there's a specific formula which you'll need to make use of whenever you do a Doppler effect calculation. This formula will be given to you at the back in test of exams in your formula sheet, so you do not need to memorize this one off by heart. But you will note though as we go along that I'm going to urge you to always first start your question by copying this formula as is from the formula sheet without any alterations, and only then once you've copied it can you go and do any changes if you feel like it. Now here's our formula. Let's quickly see what it stands for. Our F with the subscript L here stands for the frequency observed by the listener. Now you would note that there is two V's. Each one of these V's means exactly the same thing, and that stands for the speed of sound in that specific medium. So if it's air, both of these would be most probably 340 meters per second. Now these values are usually given to you, unless they give you all the other values and want you to go and calculate them. Now for example, if this was done in water, it will be around about 1,500 meters per second. But as said, that's most cases usually given to you. Now the plus and minus signs that follow after this, remember to still copy the formula as is with these plus and minus signs when you do a calculation. This will actually indicate the direction. Now we will talk about the direction shortly once we have done everything concerning our formula here. Now we're going to go over to VL. Now that is just the velocity of the listener if it is moving. Our next one is VS, and that will be the velocity of the source if it's moving. And the last one F is FS, which stands for the frequency as emitting the sound. So this is seen as the frequency of the source. So these are all the subscripts that is necessary. Usually it's L and S for listener and source, and then just these V's are usually the constant for the speed of sound in that specific medium. Now let's look at a few tips when you have to do a calculation. First thing that is important is to go and draw a picture of the scenario of the question. Sometimes a picture is given, but in many of your Doppler effect questions there is no picture given. So always go and draw one for yourself. Second tip is you need to indicate direction. Do that even before you're going to start your calculation. Now because velocity is involved and velocity is a vector quantity, that's the reason for us indicating a direction. Now it is best for you, and it's easier, you can do it the other way around if you want to pick a direction from the listener to the source as positive. Let's just look at an example. So in my case, I'm going to have an ambulance. This is going to be the source of the sound due to its siren, and I'm going to have a person standing in the road. This person will now be the listener. Now I will always pick from the listener to the source as positive. Now in this case, my ambulance were moving towards my listener. And that then means if I've decided that from the listener to the source is always positive, this ambulance is moving in the opposite direction to that, which means it will be a negative velocity. So that usually means if I go back again to my formula, our velocity values here at the bottom would now be the velocity minus the velocity of the source, because it's going at a negative velocity. But we'll do a whole calculation as well to explain it. Most important thing is always pick from the listener to the source as being positive. As mentioned to you earlier as well, always copy that formula as is from the formula sheet. Don't alter it yet. And only once you've copied it as is, you can then go and manipulate the formula by putting in plus and minuses where need be. Now let us quickly go and do an example and see how we fare. The example starts off by telling us that a fire truck with its siren on is moving at 25 meters per second towards a burning building. Now a person standing on the side of the road hears the frequency emitted to be 500 Hertz. The frequency heard by the listener, though, is higher than the frequency emitted by the source. So the listener hears it at 500 Hertz, but it's higher than what the source actually emits. Now the first question would ask us, is the fire truck now moving actually towards or away from the listener? Now the key part lies in the fact that they tell us that the listener hears it at a higher frequency, which means if it is a higher frequency, the wavelength was shorter, and that means that the waves was compressed in the front. Therefore, this specific fire truck is then moving towards the listener. Secondly, explain why this frequency observed is higher. Now you will always start off by saying, in this case, the waves are compressed in the front, which means a shorter wavelength. That means an increase in frequency, and then we go over to the fact that it's a higher note. So it's always in the order of wavelength, frequency, and then the high or the lowness of the note. So waves are compressed in the front, shorter wavelength, higher frequency, thus a high note is observed. Last part of this question, go and calculate the frequency of the siren if the speed of the sound in air is 340 meters per second. Now let us quickly go back again to see what we have and what gets asked. They want us to go and calculate the frequency of the siren. We have been given in our question the frequency as observed by the listener to be 500 Hertz. We also heard that the source speed was 25 meters per second, and they told us that the speed of this medium is 340 meters per second. So this is what we've got. Now let's quickly go again back to those tips that I've given you on answering a Doppler effect question. The first one was to go and draw a picture. So let's first do that. So I've got my listener standing on the side of the road, and I've got, in this case, the fire truck moving towards him. Now, second one was to always indicate direction, and for ease sake, decide to take from the listener to the source as being positive. That means that my fire truck will be moving at a negative velocity. Now from here onwards, in order to do the calculation, we first need to copy the formula as is from the formula sheet. And only now can we go and manipulate it. Now let's quickly go and punch in the values that we do have. We do have in this case the frequency of the listener. This is 500 Hertz. And then from here onwards, we've got the V's in both cases. It's going to be 340. But let's just now first see. Following after these V's are now the velocity of the listener at the top part, and at the bottom the velocity of the source. Now first off, we said that our listener was standing still, which means this velocity of the listener is actually 0. Now we are not going to include a plus and minus 0 here. Because it's 0, we're going to leave out the rest of the part on this part of my calculation. At the bottom though, note though, the fire truck was moving towards our listener, and we realize that is a negative direction. So therefore we're going to end up saying negative 25 meters per second, and then we want to go and calculate the frequency of the source. So we can go and simplify it, and then from there onwards go and determine our final frequency of the source to be 463.24 Hertz. Remember to always round it off to 2 decimal places, and frequency is measured in Hertz. Now there's also a few applications of the Doppler effect. You do need to know some of them, and you will find that in your textbooks they do refer to it as well. Now there is 2 of these applications that we do find in the medical and the sciences part. Now we first off make use of the Doppler flow meter. Now that's just a device that they will attach at the top of your arm or any place where there is a proper veins and arteries moving, and then they will in this case send out an ultrasound towards your arteries, and that ultrasound, once it's been set out, will get reflected back, and this is how they will be able to measure the flow, and in this case the specific speed of the flow of blood. Second one, also in the medical sciences, is where we still make use of this Doppler flow meter, but to measure the heart rate of a fetus. Now there's one more type of application that we will be looking at as well, and that's when we look basically as a Doppler effect of light. Now when you have astrologers that actually view the stars, you would note that they've realized that as they look at the stars, and remember there's bending of light in space, they would then see a planet as either a blue or a reddish color. Now that just tells us, is this planet moving away from us, or is it coming towards us? Now roughly sketched here, if this planet is in this case moving towards us, note though that the wavelengths are compressed in the front, and that means a shorter wavelength but a greater frequency. Now if we look at our visible spectrum of light again, we would note though that the red light usually has the longest wavelength of the lot. So they're basically seen as a high wavelength, but and that means a lower frequency. As we move over to the other part of the spectrum, to the green and the yellow and the indigo and the violet, they've got a shorter wavelength but a greater frequency. So if we go back to our scenario where this planet might be approaching us, that means we as Earth are here in the front, then we would see it as a short wavelength and a high frequency. And a high frequency referred to the colors like blue, indigo and violet. So we would see it like as a blue or purple color as it comes towards us. If we though on the other hand are behind this planet, which means it's actually moving away from us, then we would have a longer wavelength, and a longer wavelength would mean to us a shorter frequency, and that falls in my red and orange and yellow colors. So we would then see this planet as this reddish orange colored of light. Now what this specific astronomers then realized is that most planets have this red color, which means that most planets are moving away from us, and that indicates that the universe is still expanding, it's still becoming bigger, and so they call it then the red shift of planets, which means that they are moving away. Now in our next lessons on 2 and 3 dimensional waves that's still to come, we will discuss this electromagnetic spectrum again in detail. Now the question which I would like you to go and attempt is: the siren of a burglar alarm has a frequency of 800 Hz. A patrol car hears the alarm and approaches the house at a constant velocity. The detector in the patrol car registers a frequency of 950 Hz. Now if the speed of sound in air is 340 meters per second, go and calculate the speed of the patrol car. Remember to take into consideration those 4 tips that I've given you, and to first pause your play and attempt it before you'll be looking at the answer. Now let's start off by drawing a picture for ourselves. Now we've got a house with a burglar alarm going off, so this is going to be the source. We've got a listener, which is then the patrol car, and note though that we said that this patrol car observes a higher frequency. Although the siren of the house is only 800, the patrol car hears it at 950, which means that it is actually then in this case approaching this house. So that's its direction. Now we also need to go and indicate a positive and a negative direction for ourselves, and we said we always take it from the listener to the source as positive, which means this motion of my listener, which is the patrol car, is also going to be a positive one. From here onwards, let's go and write down the formula as is from the formula sheet. Now I've got the frequency as heard by the listener, that's the 950 Hz. The velocity of speed in air in this case, of sound in air is 340, and the listener now in this case was approaching this house, which means it's traveling at a positive, we've realized, velocity, so plus the velocity of the listener, which we want to go and calculate. The house though was stationary, so therefore we're not going to include a plus or a minus here at the bottom. Multiply that which the source in this case emits, which is 800. Now from here onwards, please do take note that this is brackets here at the top. First do away with your 800 by saying 950 divided by the 800, and then from there onwards you can multiply by the 340, which was here at the bottom, to be left with the 340 plus the velocity of the listener. Now from here onwards we'll find the velocity of the listener to be 63.75 meters per second. Now the next 2 lessons we'll be looking at typical exam questions which they will use to try to catch you out.